Welcome to this tutorial on ArrayList, which is part of our PowerShell Collections series. In this video, we'll explore System.Collections.ArrayList, a powerful feature for managing dynamic arrays in PowerShell. Understanding ArrayList will help you write more efficient scripts when dealing with collections of data that need to grow or shrink during runtime. Let's dive in and discover how ArrayList can improve your PowerShell scripting performance. ArrayList is a non-generic collection type in PowerShell that can store objects of any type. Unlike regular arrays that have a fixed size, ArrayList automatically resizes itself as you add or remove elements. This makes it extremely flexible for scenarios where you don't know the final size of your collection in advance. ArrayList belongs to the System.Collections namespace, which is part of the legacy collection framework in .NET. It provides a simple yet powerful way to manage dynamic lists of items without worrying about pre-allocating space. There are several ways to create an array list in PowerShell. The first method uses the new -object cmdlet with the fully qualified type name System.Collections.ArrayList. Alternatively, you can use the .NET type accelerator syntax with square brackets, calling the new method directly. This approach is more concise and modern. You can even simplify it further by using just collections.ArrayList as the type name. All three methods create an empty array list that's ready to store your data. Choose the syntax that best fits your coding style and script requirements. Adding elements to an array list is straightforward using the add method. When you call the add method, it returns the index of the newly added item, so it's common practice to redirect this output to null using the greater than symbol followed by $null. You can add any type of data, like strings, numbers, or even objects. For adding multiple items at once, use the addRange method, which accepts an array of items. This is more efficient than calling add multiple times in a loop. Remember that ArrayList can store mixed types, so you can add a string, then a number, then another object type all in the same collection. Accessing elements in an array list works just like accessing array elements. Use square bracket notation with an index number to retrieve specific items, where 0 is the first element. To find out how many elements are in your array list, use the count property. The contains method checks whether a specific value exists in the collection and returns true or false. If you need to know the position of an item, use the indexOf method, which returns the 0-based index of the first occurrence of the specified value. If the item isn't found, indexOf returns -1. ArrayList provides several methods for removing elements. The remove method deletes the first occurrence of a specific value from the collection. If you know the index position, use remove@, to delete the element at that specific location. For removing multiple consecutive elements, removeRange takes a starting index and a count of how many items to remove. Finally, the clear method removes all elements from the array list, effectively resetting it to an empty state. These methods give you fine-grained control over managing your collection's contents as your script executes. ArrayList has both advantages and disadvantages you should consider. On the positive side, it offers dynamic sizing that automatically adjusts as you add or remove items. It provides easy-to-use methods for common operations, and it allows flexible storage of different data types in the same collection. However, there are some drawbacks. ArrayList suffers from boxing overhead because it stores everything as objects, which can impact performance. It's not type-safe, meaning you can accidentally mix incompatible types without compile time warnings. Additionally, ArrayList is generally slower than modern generic collections due to this boxing and type conversion overhead. As a best practice for modern PowerShell scripting, you should prefer using list_of_t or generic .list instead of ArrayList. These generic collections provide type safety, meaning they only accept items of a specific type, which prevents errors and improves performance by eliminating boxing overhead. However, ArrayList remains useful when working with legacy code or in specific scenarios where you genuinely need to store mixed types in a single collection. Understanding ArrayList is important for maintaining older scripts, but for new development, Embrace the type-safe generic collections for better performance and reliability.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.